and for the participation. Question 3 is, when you're taking a sample size of n equals 5, what is the shape or the distribution of means, histogram, when the parent population is right skewed?
Right, okay. So have we looked at this material, or do we have any guesses on this yet?
Yeah, I did the homework. Understood.
Good job.
Yeah, I understood like 70% of the way. So,
Yes.
Cheryl, do you have any ideas?
So for me, on that one, was the last part of that say the parent population is right skewed?
Yeah.
Yeah. So I went with it will still remain right skewed.
Yeah, I did too.
That sounds right.
Okay.
I don't know, see if my thing is loaded yet. Let's take a look.
And does the exact sample size, is that really significant?
Go get into Jen.
I think I'm not sure if wait, was that a question?
No, I just mentioned that the sample size happened to be n equals 5, but I don't think that really is super important.
So the sample size is going to be important for it to be a normal, no, for it to be, yeah, I guess it could be called a normal distribution. It just has to be above 30. So like if that's not right, you're probably not going to get that.
Okay.
But then at the same time, if the question itself already says that it's normal, but then it talks about how it looks with the parent population, then you just stick to that and don't have to worry about the number.
Okay.
Sorry, my 2-year-old is demanding to eat right this minute.
No worries.
All right. The next question is, when you're taking... All right. Did it pull up for you?
Yeah, it did. So go ahead, sorry.
No problem. So when you're taking a sample size of n equals 100, what is the shape of the distribution of means histogram when the parent population is right skewed? So in this case, it would be normal, right? Or no?
That's,
yeah.
Yep.
Cool. I'm learning.
Good job.
Okay, I'll let someone else do number 5.
Mom.
Okay, I'll do number 5 and then somebody does the next one.
Okay.
So it says when you're taking, and then correct me because I want to make sure we're in the right order. So when you're taking a sample size of n equals 5, what is the shape of distribution of means histogram when the parent population is normally distributed? So with that one, I went with normal.
Yeah, because it would match in this case, right?
Uh-huh.
Okay. Cool. Sounds good.
Sorry, guys, just a minute. I'm sorry. I'm going to have to be just right back.
No problem.
Go ahead.
After, do you want to take number 6?
Sure. Come on. So it says you're taking a sample size of any shape of the distribution when the parent population is normally distributed. That would also be normal.
You said normal. Yeah, me too.
Sounds good.
All right. This one's tricky. Who wants to take this one?
Which one?
Question 7.
7? Sorry. I can do that one.
Okay.
When would the distribution of means be normally distributed? So the 4 questions differ based on the population that is normal, and with a small sample size, population that is normal with a large sample size, population that is right skewed with a small sample size, and right skewed with a large sample size. So we know that if it's normally distributed, then if the population is normally distributed, then it will be normally distributed, the means. So the first 2, I would say, since they're both normally distributed, and then we also know that if the sample size is large, then it will also be normally distributed. So I would say the first 2 and the last one based on the large sample size.
Yeah, I think that was awesome. I could never have explained all that, but yes. That's awesome.
Okay.
Does anybody have any questions on that? Or was, yeah.
That sounds good. So you were saying in general the rule is like a sample size of 30 is kind of where it changes.
Uh-huh.
Sorry, it's really hard
Okay.
to hear you guys, so I might have to hold it close. So don't think I'm weird if I'm holding you up to my ear.
Yeah, basically, if the sample size is at 30 or above, you're gonna guess that it's going to be normally distributed. So she's right as far as the keyword being a large sample size. But then she was really awesome to also just look at the word. So if it says normally distributed, regardless of the size, it's already normally distributed, so we don't have to worry about it. And then she picked the right skewed one because the sample size is large, which would then again give us a normal distribution.
Nice.
Yeah.
All right, well, I can do question 8.
All right.
So which of the following gives the best explanation of the central limit theorem? And rather than read them all, I was thinking it is C, is that right?
What does yours say for C?
If the sample size is large, the sample mean X bar will be closer to the population of mu.
So I differ from that.
Okay.
Yeah, I believe it's if the sample size is large, the shape of the distribution of the sample means will be approximately normal.
Okay. Sounds
I
good.
think it's, my guess would be the last one, because when we learned about central limit theorem, they were talking about shape. And so the last one deals with the shape of the distribution of the sample means normal. I don't know if that's exactly right, but that's what shape stands out to me.
Yeah.
Cool.
If you guys would like, I can, do you guys have the definitions for the central limit theorem and then the definition for the like population mean?
I think I've looked at them, but you have an easy way to share it?
Let me see. So the central limit theorem is just as the sample size number increases or becomes large, the distribution is normal. So that's just the only thing about the central limit theorem is talking about the sample size.
Okay.
So maybe not the word shape, but the word that it says approximately normal. Is that like the giveaway?
I think that giveaway for this one is because let's see. Yeah, so the giveaway for this one is probably going to be, yeah, I think you're right, because the sample mean becomes normal after it's large. So yeah, that's why. And then the other one,
it talks about population, which is what we talk about in the law of large numbers, right?
That's correct. So the one that you picked originally, the sample size is large, but the one that says the mean is closer to the population mean, that's the law of large numbers.
Okay.
Mm-hmm. All right. So let's see, number 9. It says, what is the mean of distribution of the sample means? So this one was really cool. It was given. So the population mean is 10.
Makes sense.
What was that?
I said makes sense.
Awesome. And then who wants to do number 10?
I can do 10.
Awesome.
I just, let's see if you plug in the formula to find the standard deviation of the distribution of sample means, the standard deviation, which is 6, divided by the square root of the sample size, which is 36, which is nice because the square root of 36 is 6. So 6 divided by 6 would be 1.
Yeah, that's cool. Yeah, the first time I did that, I was I did it wrong. I went ahead and put 6, but it's when it wants the sample means, then you have to do like the standard deviation formula. Cool. Somebody want to do question 11?
And so regardless of the distribution of the population, if the sample size is large and greater than what would the shape distribution of the distribution of the sample mean?
Yeah.
Sounds good. And then what theorem would justify your response to the last question? I'm doubting myself. Central limit then?
Yes.
Okay. Good. I just got them mixed up earlier.
They're really close.
Yeah.
Mm-hmm.
So when it's talking about the shape of distribution, the key word there was distribution becoming normal again. And that's just the central limit theorem. Sweet.
All
So if
right.
you guys want to submit and see how y'all did, if we missed any, we can check it.
I've submitted them so far. I don't think we've missed. Got them all right.
Yay, looks good.
All right, cool.
Awesome.
Thanks so much.
Awesome, guys. Is there any other questions before we take off?
When's the next meeting?
Oh, can we plan for Thursday? Even if we do around this, like at 5?
That works for me.
For me.
I'm actually flying back from Oklahoma on that day. I live in California. So my flight gets in at 4, which would be 5 o'clock Mountain Time. Can anybody do 6?
Yeah, 6 still works for me on Thursday.
I start work right then.
You start work at 6?
Yeah.
Okay.
Okay.
Yeah, I'm trying to think
I'm
because
sorry. Normally I wouldn't have it this complicated. I promise I'm done going out of town after this.
No worries. Let's look at the due dates and then we can see what's going on because I know we have 2 assignments we need to meet. Okay. Let me look. I just don't remember what the days are. Let's see. It's still loading for me.
I mean, since these meetings always seem to be like about 15 minutes anyway, it should
Yeah.
probably be okay. I can just go to work a little bit later.
Well, and depending on when my flight lands, I think I can do Hangouts on data. Has anybody done that before?
I have no idea. That
Okay.
totally beats me. But let's see.
So,
We don't. Let's see. This is for lesson 7. We're talking about doing the group hangout again, right? That's. It says it's due by October 5th. Oh my gosh, cool. Okay. So what if we just met tomorrow?
I have another group meeting for another class tomorrow.
Yeah.
And we're working on a project.
So I guess, I mean, we really only have tomorrow and the next day. So
When is your meeting?
What about
did
early times?
5:30 on Thursday?
Yeah, that works for me. 5:30 or again 6. I can do because it seems like I'll be less than 30 minutes late.
Okay.
Are you sure?
And you know what though? Honestly, if we meet at 6 and then you have to take off, that's okay. We'll still count your contribution. Like I just usually will leave a note like everybody participated or something.
Yeah.
Okay.
And I'll still post everybody's name on there. So
Okay.
let's do Thursday at 6 and we should be good.
Sounds good. And yeah, Cheryl, if anything like your flight gets delayed or something, just let us know and we can work with that.
Okay. Yeah, I'll
Yeah,
keep
you
you
can
guys
even
in the loop
text
as much
us.
as I can. Thank
Yeah.
you.
We can, yeah. All right, bye guys.
Bye.
Thanks.